G'day there. You're watching the Aussie Boom Guru, and today I'm revisiting a topic on the channel, which is placing views onto sheets using Dynamo, and we're going to be using a fair bit of Python in this workflow, so we're not going to use any custom packages. So this has come a few times on the channel via request, so I hope people find it useful. So we'll be looking today at processing a Excel file as a set of instructions for Revit. We're going to be matching views by name and also sheets by number, and then looking for matching viewports to line up those views to and place them on the corresponding sheets. We're going to build a fairly thorough error report to indicate what things may go wrong in the process, because placing a view onto a sheet has a few things that can go wrong. For example, maybe no view exists with the right name or type, maybe no sheet exists by that number, maybe the view's already placed onto a sheet and can't be placed again, or maybe the matching viewport ID isn't available for the script. So we're going to detect all of those errors and report them out to the user. So if any of them don't work, they have a really good understanding of why. So today I'm going to be using Autodesk Revit 2023 in this case, and Dynamo for Revit. I'm also going to be using Python 2.7. It is my preferred dialect of Python at the moment. You can try this in CPython, but there will probably be some differences. Generally, I find CPython has a lot of issues and quirks and sometimes can't do what I want it to do, especially in Dynamo, so I tend to avoid it. So you will need the custom extension installed via the package manager, DSi Python 2.7, to follow my workflow exactly as I do it. I'm also going to be using a boilerplate you can find over on my GitHub, which contains a few references you require in order to talk to the Revit API via Dynamo. So you will have just a little bit of assumed knowledge probably if you're following along with a full understanding. So obviously you hopefully understand the principles of Revit and Dynamo to some degree, and just have some understanding of Python fundamentals. If you don't, feel free to check out some videos on my channel because I do cover a lot of those areas. I will try to touch on the areas of the API that I'm using today using Revit API docs. So hopefully that will help at least understand some of those newer references that I probably haven't talked about on the channel in depth. So without further ado, let's dive in. I'll just run through a starter model that I've set up and then we'll get to it. So I've just set up a basic project. I have a ground floor plan which has a larger scope box applied to it, and then a few floor plans for levels, in this case with a smaller scope box. So we're going to be aligning two different viewport alignments. One of them will be our major ground floor alignment. The other one will be our levels, which are further up, which will have a smaller scope box, so will be positioned a little bit differently on the sheet. So you're going to need at least the views and the sheets that are available to place these elements onto available. You're also going to need at least one viewport to reference per type of view that you wish to place. So for example, I'm going to place one of my ground floor plans at the desired location. I'm also going to note in this case the ID of this particular scope box, because on the side I've prepared an Excel file which contains the name of the plan I would like to place, the plan type without the space, so as it actually reads in the Revit API, so floor plan, ceiling plan, area plan, engineering plan, depending on the type of plan, and also the sheets that you're trying to place them on by number. So I'm going to say in this case that ground floor ID is going to be this number here, and we're going to also use that same viewport to place any other ground floor plans. So I'm just putting in the element ID. I have made sure this column is read as text as well, just so it doesn't misinterpret it as a number when it comes into Dynamo. As well as this, I'm also just going to place at least one plan maybe up here for the smaller plans. And already we're going to trigger an error in our script if we don't run this carefully, because we want to place all of these the same way. So I'll just copy this and say these all match that viewport instead. But already we have two views placed in our Excel file. So when we send the instruction to Dynamo to place this plan on the sheet, it's already placed, so it's going to trigger an error. It won't be able to work this way. Likewise, if we had a view that we wanted to place onto another sheet and the sheet or the view name isn't available, we're also going to hit an error. So I've also intentionally created a few errors in this file. For example, there's no level 4 plan in the floor plans. As well as this, there's no level 4 sheet for the RCPs. So we're going to build the script in a robust way where instead of sending errors to Dynamo and causing the script to fail to run, we're actually going to catch all these scenarios as we go and make sure that the view can be placed, and then we will place it if it can be, and if not, we'll say, well, why couldn't it be placed for the user? This is how I tend to build this workflow these days. Typically in PyRevit is my home platform for this workflow, but I really prefer that scripts talk to the user. They communicate with them effectively and tell them what's wrong. That way, if an error happens, they don't lose confidence in Dynamo. It's a really big problem in large companies, especially like the one I work at. If a tool doesn't work as intended, users will usually be very turned off by Dynamo, and it's very hard to get adoption. So that's why I'm really focusing on this today. So let's just jump straight into Dynamo and make a new script. And it's going to be in dark mode because we are in 2023. I am going to go to manual mode for now. So to begin with, we really just want to collect this Excel data, and we're going to read from the first row, or the second row. I'm thinking programmatically here. We're going to read from row 2, and we're just going to scan for all of this data. So in this case, I'm going to be using the Open XML import Excel. It's much more reliable than the typical import Excel. There's lots of issues with the standard import Excel node that probably a lot of people know about. Primarily that if you have a Windows update, it often prevents the standard Excel nodes from working because the API gets knocked out in the Windows update. So for now, I'm just going to build in the assumption that the sheet is called sheet 1. We're going to start at row 1 and column 0. And I'll just say by default, we're just going to leave that read as string alone. We'll just let it be read as we want. So what we should have now is, once I hit run, we'll have our data from the top of the file down. Now we are going to want to transpose this data. Sometimes I do like to put string from object after here. I find sometimes the read as string input can cause an error here in the Open XML import nodes. Seems like it didn't this time, but I have seen it do it before. So sometimes I find it is more stable to actually string from object after, depending on how it reads the data. There we go. So we can see these are all still the same, but strings. But I found sometimes it works, sometimes it doesn't. Maybe for now, given it is working with me, I will say true, and just hopefully this keeps working. Cool. So I'm going to transpose this into rows from columns, so columns from rows, I should say. And we're now just going to process our data a little bit to set it up for a Python script. So what we're going to do here is I've intentionally sort of told each of these plan views what type of plan they are, because you can have a ground floor plan and an RCP, both called ground floor. So I wouldn't be able to find this floor plan by unique name because there would be more than one view with that name. So I also have to inform this view what type it is, and I can combine these together in order to find the matching plan view if it exists. So what I'm going to do here is close my Excel, and I'm going to say that the view plan name that we're looking for, or VPN, which I'm calling it, is going to be the second column. So in this case, the type of plan that we're dealing with plus underscore as a string plus, and I'll say data 0 in this case. And when I feed this in, it's going to work across the lists. And we can see now we have a hopefully unique string that we can search for when we use the Revit API in the Python script we're going to build. I then also want to say the sheet that I'm looking for, SHT, is equal to data 2. So we're going for the third column. Now we can see we're getting our sheet numbers. And I also want to say the viewport ID is equal to data 3, the fourth column. And now we have our IDs that we're hunting for. I'm also just for later going to return the sheet plus a comma plus the view plan name, because we do want to report later on any sheets that don't work, and showing the intended sheet number plus the type and the name is a really good way to make it obvious what sort of thing we were looking for at the time. It's up to you how you want these things to look. We're going to need to be consistent with this in our Python node to some degree. Okay, so I'm just going to save my script just in case I crash out, which hopefully won't happen. Probably jinxed it now. So we're going to create a Python script, and it's going to have, in this case, 2 inputs, and I'm going to switch my Python engine version to IronPython 2. I can do that because I do have a custom package installed to support IronPython. If you haven't got it, you're probably going to want to do it. Otherwise, there's probably going to be some errors in Python 3, and I'm not going to bother troubleshooting Python 3 errors. It's just not worth the time in my experience. So we want to get that DS IronPython 2.7. So from there, I'm going to take first input, second input, third input. So we're dealing with the view name, the sheet number, and the viewport ID as strings or text. Okay, so I'm now going to switch into Python, and I'm going to get my boilerplate by default, which does come with my Python template. So I've set that up in my Dynamo app data folder. So there is a template. I'll show you quickly how I've done that, just in case. So back in Dynamo Revit 2.13, I believe it might actually be 2.12 potentially. Just double checking. It's usually somewhere somewhere around here. Interesting. Doesn't seem to be drawing it in. Yeah, it seems to be just going back to this Python template, I guess. So generally you'll need a Python template. So what this is just a Python script with my standard boilerplate. You can find this on my GitHub under my miscellaneous repo if you need a copy. But effectively, if you put it usually in the respective Dynamo version folder, I guess in this case it's just drawing it from 2.3 by the looks of it, it will basically set you up with that boilerplate inside the Python block. So I'm going to get rid of some things in my boilerplate. I'm going to keep the common language runtime reference. I'm going to get rid of protogeometry and system. And I'm going to get rid of geometry conversion. So we are going to use the toDS type method later on to convert object back into a Revit object at the end, just to tell the model that we've created in Dynamo and we want to give it back to Revit. We now have the Revit services, which lets us call on the current document and exchange and transactions with the Revit DB. And I'm also just going to get rid of the Revit API UI references. So if you do want to manually type that out, go for it. It's on the screen right now. Probably a little bit hard to read. It's probably not quite big enough. They have added a zoom option to Python in 2024, which is most welcome. But would have been nice to have it in every other version of Revit. But I guess that's how the ball rolls. So I'm just gonna, in this case, just keep the current document, which is document manager instance.currentDB document. I'm going to get rid of my standard inputs and we're going to reference our inputs instead. So I'm going to say XCL views for Excel views is going to be in 0. So in is the standard reference we use for inputs. Excel sheets is in 1 and Excel viewport IDs is in 2. And often I like to just space these out so they all stack on the equal sign, much more friendly. I'm also going to have some lists of things that I'm appending to and working with, so I'm going to see if I can get... Actually, I probably don't. No, I don't actually need those. Never mind, we can skip that part. What I'm going to do next is actually collect all the plan views and all the sheet views in the model. So I'm going to say all plans and sheets. And what we're going to do here is use a pretty commonly used class in the Revit API, the filtered element collector, which is a class in itself. And it has various methods you can pass to it. So in this case, we're going to be dealing with the collector method of class, and we're going to be targeting both the viewPlan class, which is a class that primarily deals with floor plan and area plan, ceiling plan and engineering plan views, and also the view sheet class, which deals with sheets. So we're going to target these. So to create a filtered element collector, we're going to firstly give it a name. I'm going to call this one plan views. I'm going to say equals to filtered element collector. I'm going to apply it to the current document as the argument. We're going to say of class, and we're going to reference in this case viewPlan, and we'll say where element is not element type. I don't believe we need this argument here, but I do use it every now and then just to be sure, because we only want to get the instances of the plan views. Some classes will share their class with type definitions. For example, if you're ever dealing with walls, wall types live inside the wall class. So if you ever want to deal with just types, you wanted to specify where element is not element type. I'm also going to say that sheet views, or view sheets I'll call them. I might call these view plans actually, just for consistency. And all we have to do is replace view plan with view sheet. And at this point, we should have those two things. So if you ever want to have a look at what's going on in your Python node, you can always put something into the out variable. And I can see now I've collected my sheets, or if I look at my view plans, I've collected my floor plan and ceiling plans in my model. So at this point, we really want to just start dealing with matching our elements. Now I'm going to build a little function here, which is basically going to take the piece of data from Excel, compare it to all the names in a big list of things, and then say, okay, in your list, do you occur? And if so, grab the thing that generated the name that originally was part of that thing. So what I'm going to do is just generate the names of all the view plans and all the view sheets in the model. So I'll say all names for them. So first of all, we're going to say plan names is equal to. So in this case, I am actually going to generate a little function to generate the plan's name, because we're not just going to get the name of the view, we're also going to get the name of the view type and also make sure that it has that little underscore so we can perfectly match our Excel list that we've just built. So I'm going to say in this case that I'm going to make a function using the def statement and say get match name. Now we're going to assume in this case there is going to be a match here. So we're going to be using an if statement later on to verify if this name exists first. Then we're going to be using this function later as well. Sorry, that's actually another function that we're building. So this one's just going to get the name of the plan view, so I'll build this one first. So we're just going to get the match name for a plan view. We assume it's going to be a plan view, so no problems. So I'm going to say the view type name is going to be equal to the view type of the plan view. So let's just have a look at the view plan class quickly. So in this case, we're looking for a particular property of the view plan, a property, I believe, called view type. View type, here we go. So the view type will return what's called an enum or an enumeration, which means there's a fixed number of values that are returned as an object, and we can convert these directly to a string. So this is why I've chosen floor plan and ceiling plan in my Excel file as the options, because they will match the enum exactly if we get it right. So in this case, I'm going to say the view type name is equal to the string representation, so str bracket, and I'm going to, in this case, take my plan view that I'm passing through the function and get its view type. So this will return the string representation of floor plan, ceiling plan, etc. I'm then also going to say, in this case, the matching plan name in that case is going to be the view type name, which we just generated, plus underscore, plus, and we're going to do plan view dot name to get the name of the plan. Finally, we return the match plan name, npm. So this function will effectively generate the same type of name that we're looking for from our Excel data. I can now use what's called list comprehension in Python to do a one-line statement here and apply my function to each view within plan views to generate a new object, which is a list of the names of those plans. This is a common technique in Python to save space and also to sometimes make more readable code. So I'm going to say get match name. So I've just opened a list there. And I'm going to apply this to plan view as a variable for plan view in plan views. So effectively I'm saying get each plan within plan views, or sorry, view plans I should say. Let's be consistent. Let's just go and actually make these all say view plan. It's a bit confusing otherwise. So I'm saying for each plan within view plans, call it plan, get its name using this function or this special name using its function, and then we're going to call these our plan names. And I believe that should work. So if we have a look at plan names, we should now have that representation of each floor plan in the model in this case. I'm also going to get the sheet names. Now this is the sheet numbers. So I'm going to say in this case, sheet numbers is equal to, and again, I'm going to do it in a single line. I'm just going to use the sheet number property of the sheet. So I'm going to say view sheet dot sheet number. I'm going to say for view sheet in view sheets. So I'm being pretty careful with my variable naming here as well. Like these are words that are very close to the class name, but I am using a syntax where the first letter of each of those is lowercase, whereas all the class references in the Revit API begin with an uppercase. So it's very close to a reserved word, but it's not exactly the reserved word. So it makes for a little bit more readable code with the risk that you are skirting very closely to a reserved word in the API. So at that point, we should now also have all of our sheet numbers. And it's important to note that these sheet numbers are in the same order as all the sheets, and likewise the plan names are in the same order as all of the plans. So in this case, I should be able to use what I like to call cross-indexing, where if I find out the position of a particular piece of data in a set of names, I can cross-index that against the objects that generated that list of names to get the same object from the matching index. So we are actually going to build a special function to do that. In this case, I'm just going to call it cross-index. And we're going to assume in this case there will be a match for the thing we're looking for in the set of names, and there will be a matching list of things. So we're going to use some if logic later on to make sure that this is definitely the case, so that we can safely apply this function without having to bury the logic within the function itself. So I'm going to say we're looking for an element within a list of elements, and then finally we're looking through a second list, and I might even, actually I'll say in this case we're looking for a name in a list of names in a list of elements. And I'll just keep them all lowercase. I'm pretty sure that should work. So I'm going to say in this case, the index that we're targeting in the other list is going to be in our list of names. What is the index of the name? And then I'm going to return, in this case, the elements indexed by that position. Yes, that works, cool. So that will effectively allow us to just really quickly ask our set of plans or our set of sheets, where do you occur, give me the sheet, or where do you occur, give me the plan, assuming they exist. So at this point, we're really ready to start building within the context of a transaction. So the transaction here will allow us to modify the Revit document. It checks out the model to some degree. It gives us permission to modify all the elements we need using the API. So in this case, we're starting a transaction for the current document, and now we're actually going to start building our function. So this is the core of the script here. It's a fairly long script. It's maybe about 70, 80 lines. So we'll see how we go. So I'm just going to call this try to place viewports. And we're going to need a few things to get us started here. So we're going to be trying to create a list of viewports at the end, and also a big report that tells us what happened in the script that we can process separately. So the report is basically going to be a list of reports built out of true or false outcomes for each step of trying to run through this process. So the first step is we're going to try and get the matching sheet. If we have the sheet, well, we know that we can place a view if we have a view. So we'll check then, do we have a view? And then we'll check, can we place that view? And finally, we'll check, is there a viewport available with the matching ID that we can reference its position on a sheet in the model? So what I'm going to do here is use what's called a zip loop. We're going to zip through 3 different lists to cross-iterate. So we have variable context for 3 lists. And we're going to be using these 3 lists from the start. I'll just fix that typo. So I'm going to say, in this case, for Excel view, Excel sheet, Excel viewport ID. So I'm taking the S off in zip. And in this case, I'm doing Excel views, Excel sheets, Excel viewport IDs. And just to check for typos, I'll just say pass and run. No typos, it works. Excellent. So I now have the access to each view, sheet, and ID in that row of Excel to work with. So very easy, off we go. So first of all, we're just going to, by default, assume there are no errors. So we're going to say set empty error state. So we're going to do 2 things. One is we're going to build a list of true and false outcomes as we go. And we're also going to start with a variable that says no error has been met at this point. So I'm going to say errors is an empty list, and error met is false. We haven't hit an error. And that way, at each step of our process, we can use that errors met variable to know if we should just skip some steps that won't work because we don't have the elements we need. So we're going to begin by trying to get our sheet based on this number. So we can actually just work with our function now. First of all, I'm just going to check, does the Excel sheet number actually occur in the sheet numbers? If not, then we know we don't want to try and find the matching sheet because it won't work. So I'm going to say if Excel sheet is in, and I'm going to check now against the sheet numbers that we get from our model. Now, if it is, then we know report, we found it. So in this case, I'm going to say errors is going to have false appended to it because we know we found it, so it's not an error. As well as this, now we can actually get matching sheet. And we can just use our function from before to cross-index this. So I just like to sometimes just grab the function, and we're going to store the sheet that we know we're going to find to a variable called sheet. So I'm going to apply cross-index, and in this case, my name is Excel sheet. My numbers are sheet numbers. And my elements are view sheets. So when this function runs, it's going to find the matching position of the sheet number that we know we can find because it's in sheet numbers. And then it's going to return the sheet at that position in view sheets. So we'll now have a sheet object at this point. As well as this, we also have to process if the sheet wasn't found. Sheet not found because the number doesn't exist in the model. So we know this is an error. Well, we're going to say else, otherwise, error report. So in this case, I'm going to say sheet is none, it doesn't exist. I'm going to, in this case, append true because we did hit an error. And I'm also going to say now that error met is equal to true. We've hit an error. We know the rest of the process isn't going to work. Our next step is that we want to actually find our plan view, but we're also going to want to make sure we can place this plan as well. So there's a special method available in the viewport class in the Revit API that we're going to take advantage of. So if I expand the viewport class, and I go to its methods, we can see that we can use this, we can use the create method later on to create a viewport, to put it on a sheet with a document, an ID of a sheet, an ID of a view, and a point. But what we're also going to use is can add view to sheet method. It's a bit of a funny method because the viewport class is really just being used here as a helper class or a helper object that's going to verify if a view can become a viewport. It's not actually going to do it, it's just going to tell us if we can. So in this case, we need a document, a sheet ID, and a view ID. So if we don't have a view or we don't have a sheet, we know that we already can't place this viewport anyway. So we're going to use a few trees of logic here to determine that outcome. So what we'll do here is say, try to get view. And again, we can very quickly say if Excel view is in this case, the plan names, then we know it must exist and it can potentially be placed. So firstly, we're just going to report view found. So we're going to say in this case, the first thing is not an error. We know that we found the view. And I'm also, just before I forget, I'm going to go and say that we hit an error otherwise. So view not found, because in that case, we're not even going to try and place the view. So we're going to say else. So we know two errors here. First of all, we know that the view doesn't exist, and also the view can't be placed because it doesn't exist. So we're actually going to, in this case, probably, we're going to be able to append two errors here. So I'm just going to say errors append true. And I'm also going to do that again. So I'm going to do that twice because we want to say both that the view was not found and it was not placed as well. And we know that we, at that point, met an error. So we're going to say error met is equal to true. So if error met is already true, it's just going to be true again. So there's no problems there if it's already true. So beyond this point, we found the view. So, okay, what do we do now? Well, now we actually need to get the view again. So we're going to get matching view. And this is so we can actually verify it's going to be placed on the sheet. So again, I'm just going to borrow this line here, just so we can use this again. And I'm going to say that view, I'll say view plan. I believe I should be able to use the word view plan. I don't think I've used that anywhere else in context. Yep, that should be fine. So view plan in this case is cross-index the Excel view, which is the name of that view. And we're going to do this against, I believe, plan names. And finally, we're going to be looking across view plans for the same corresponding floor plan. So now that we have this one, we need to actually see, can it be placed on the sheet? Now, there is a scenario here where the view might exist and it might be able to be placed on a sheet, but we might not have a sheet available. So we need to be careful. So I'm actually going to say if the sheet is not equal to none, because there is a chance here that the sheet might not have been found even if the plan was. If it's found, we're going to check if the view can be placed on it. Before I forget, I'm also just going to go to the no sheet found outcome because I don't want to forget to add this nested loop or this nested condition. So I'm going to say else. And in this case, we know the sheet wasn't found. So in this case, we can say errors append true because we didn't find the sheet. But at this point, we've got the Excel view in plan names. We've got the scenario with two errors, but at this point we've had one non-error, but then we can have an error at this point. So we only need to append one error to this particular outcome. Again, error met equals to true. You could probably use a function to handle the error report yielding, but for now I'm just going to keep it simple. So now we're working within this last scenario where we have a plan. Now we want to find out if we can place it. So I'm going to say if, and I'm going to say viewport can add view to sheet. So at this point we know the sheet and the plan both exist and we have them available as variables, so it's in a safe state. I'm going to firstly specify the first argument is the document, then the sheet ID, then the view plan ID. And this will send either a true or a false outcome. If true, we know we can place the view. And the last thing we'll check is the viewport actually a valid thing to reference? So I'm going to say, first of all, report it can be placed. So in this case, we can now say errors append false because there's no error. But otherwise, report that it can't. So again, errors append true. And then error met will be, in this case, true. So there's a lot of scenarios we're trying to pick up here in conditional logic. That's probably the hardest section of the script in terms of the nesting of if-else statements. And I believe we'll probably run it at this point and we can see it's working. So the last thing we need to check is actually, well, can we actually reference a viewport with a matching position in the model? So we're referencing at this point a viewpoint ID, which is currently a string. So we're going to need to convert this thing into a element ID, or try to. So what I'm going to do here is deal with the last thing, check viewport has a location and exists. So I'm going to be a little bit lazy here. I'm going to use a try statement, which just means we're going to try and do this. And if we can't, we know it's not going to work. So I'm going to try, firstly, to get viewport location. So first of all, we need to actually get the ID of the viewport. So to do this, we're actually going to have to turn this string into an integer and then turn that into an element ID. So the element ID is actually a class in the API as well. So the element ID class has a few constructors, ways to create them as objects. So the one I'll be using in this case is just taking in an integer. We can see we just specify element ID plus the integer that represents that ID, and it will return the matching element ID object. So what I'm going to do here is, first of all, I'm going to have to take the viewport ID from Excel viewport ID. And in this case, I'm going to be converting that to an integer. And then I'm going to be using that integer as the element ID argument. So there is a chance at this point that that actually doesn't generate an element ID. But luckily we're inside a try statement. So if this doesn't work at any point in the process, it's going to let us detect that happens. So we should have an ID at this point. We're then going to say, in this case, the viewport, so the actual viewport we're targeting, is going to be retrieved using document.getElement. And we're going to send that ID. So again, getElement is a pretty common method that is good to be aware of. It's a method applied to the document class, or a document object. Here it is. So we can send, in this case, a element ID inward. I believe it looks like you can send a string as well, but I'm not a huge fan of that because I think you have to send a unique ID. Yeah, you can't send an element ID string. So in this case, we're just basically saying get element to the document class, which this belongs to, and then the ID. And this will return the actual object in Revit. So now we should have a viewport if this has worked. And finally, we're going to get the point, which is at the center of the viewport. So in the viewport class, there's a method we can use called getBoxCenter. And we can see getBoxCenter will let us return what's called an XYZ object. In this case, a 3-point float, I believe, might be a term for it. And in this case, we're getting a box center as a point in the Revit API, and we can use this to also reference the point when we go to place the viewport as well. So we can say, in this case, viewport get box center. Now, even if you don't have an argument to pass to a method in Python, you'll generally have to put a closed set of brackets after it to indicate it's a method and not a property, because sometimes you can have methods with optional arguments in them that you don't have to specify. So this syntax is always necessary just in case under that scenario it could happen. I think that's why they built it in Python that way. And finally, we can report no error, because if everything worked in this try statement, we know that it's worked. So at this point, I can say errors append false. We can also say if it didn't work, error. And we can do this using the except statement. So try and accept sort of come in a pair. And the except case will be, in this case, point is none. Errors will be true, and error met is also true. So at this point, we've got hopefully a point, a sheet, and a view if we haven't hit an error. So this is where the error report is really useful, because we can now just say if error hit, don't pass, just don't do anything. So I can say if error met, we're going to say the viewport we create is none. It's not going to exist. It's not possible. So we just skip running some bad code. But I can say otherwise, we know it's going to work because we've got all the conditions required to create a viewport successfully. So I'm going to say viewport is equal to, and we're going to use that argument, that method we saw before to create a viewport. So viewport create. In this case, we need the document, we need the sheet ID, which we know exists. We need the the view plan ID, which we also know exists. And we also need the point. After we create the viewport, we'll also use the 2ds type to turn this into an object that we can pass through Dynamo safely, which also, using the false flag, tells Revit that this was created through Dynamo in the Revit model, and we just want to give it back. I don't believe that's necessary, I'm not sure. I tend to do it with any object that supports it. Finally, now that we're done, we can append the outcomes. So to viewports, we're going to append viewport, and to report, we're going to append the errors. So we're going to end up with a list of errors reports, which are a list of booleans, and we'll have a list of viewports where there'll be none if they failed. So we can just get rid of that. We close our transaction using transaction manager instance transaction done, or transaction task done. And then finally, we just want to send out these two variables. So I'm going to send out viewports and report. I'm just going to try and run this. I'm pretty sure this should work. I might have made a typo. It is quite common in Python to make typos. But I feel like I've done a pretty good job here. Hopefully it works. Run. Cool, it worked. So we can see a few things have happened here. Let's just have a quick look. We already had ground floor placed, so that is what it is. We can see level 1 is there because we placed it, but level 2 has been placed matching level 1 on the right sheet as well. Likewise, level 3. Now level 4 wasn't placed. Well, what happened? Well, in this case, we know that the floor plan doesn't exist. Ground floor RCP has not been placed, in this case, by the looks of it. I thought that one would have been placed. I'm quite surprised by that. A2000. I might just check my data there and make sure I haven't made a mistake, because I thought that one should be placed. Ground floor, ceiling plan, A2000. Oh, okay, there we go. So actually, I've made an error here. Notice that ground floor is actually 2001. This should actually be 1, 2, 3, 4. So no, it's good. The script got it right. I made an error. So what actually happened here is 2 probably got. Oh no, they got. Okay, so these sheets have the wrong numbers. That's why. So this should actually be 1, this should actually be 2, this should actually be 3, and then we don't have a 4. So I'm actually probably just going to rerun this with a different condition potentially, because we might not get a good reflection. I'm just going to rerun this process again in 1. I'm just going to get rid of anything that would have been placed in that action, and then we'll just rerun it, just so my error state and my Excel file clearly reflect each other in intent. So I'll just reopen my script, ignore the error, hit run. Okay, now that looks like it's worked. So we can see everything's found. We haven't been able to place ceiling plan 4 because the sheet doesn't exist, but otherwise it looks like we've been successful. So from this, we have some outputs we can process. We have our list of viewports, and if we don't have a viewport, it will be none or null. Likewise, we have our lists of errors, which we can then process as well. So I'm going to process the rest of this in Dynamo. So I think it's good that this block of Python just does a really clear set of instructions. Try to place viewports, then report the outcomes. I think it's very clear if you just get the Python block to do a very obvious thing. So in this case, the rest of this will just be done in Dynamo. So our out list currently has 2 objects. So I'm going to say that viewports is equal to out indexed at 0, and errors is equal to out indexed at 1. Now I might be able to run this safely without making, yeah, cool, okay, I should be able to make changes, because if you reran this Python script again, actually no, you can see, in this case, they've all been turned into nulls because they were already placed, I believe, or Excel wasn't. read successfully. Something funny's happened there. I might just close this and try again. There we go. So in this case, they're all placed, good to go. I'm just going to go into automatic mode now, just so that these start flowing through live, so I can do like live testing whilst holding on to these objects that were created in Python. If I ran manual tests, it would potentially try to rerun the script and not be able to place any of the viewports, so I wouldn't be able to deal with the current state of error reporting. So one thing we can do first of all is just tell the user which viewports were created. Now it's up to you whether you want to remove the null outcomes from here or if you want to keep the same order as your Excel file. You could just list clean, which will get rid of all the viewports, so it should. It didn't. Why didn't it? Oh, preserve indices false. So that should get rid of the nulls. So now we just have the viewports by ID. It's not super useful without seeing the nulls, but we can probably look at that more specifically in a different error report. So I will do this for now. This is one output. Viewports created. And I'll also rename this node and make sure it's an output. I'm going to go back and make sure this is an input. Maybe just to be friendly, I will make this an input as well, which by default is sheet 1. And I'll just call this worksheet name, and we'll just instead do that. Now that's probably going to rerun the Python script actually. Yeah, that probably did rerun the Python script. Just double check. Yeah, it did, bugger. Okay. Redo. Run again. I'll just go into auto. It's already in automatic mode. Cool. So it ran. And we're really just in a debugging mode at the moment where we can keep dealing with our upstream data. Okay. So there's our viewports. We're just going to put that off to the side for now. So what I'm going to do now is actually process a list of errors that will explain to the user what happened. So I'm going to put these outside the Python script so that if someone does come in and doesn't really understand Python, they'll still be able to see what the errors are saying. Let's say there's a typo on one of the errors. They don't want to have to go into the Python script just to change the error name. So error 1 is sheet not found, and I'll just make a list. The other one is view not found. The other one is view cannot be placed. It may be because it doesn't exist, or it might be because it exists but cannot be placed. And then finally, I'm going to make the last one reference viewport not found. And this will just give me a list of 4 objects that I can use to report the errors. And I'm going to use a filter by Boolean mask at level 2, longest lacing to mask based on these outcomes for these messages. And I'll just be left with lists of the things that went wrong in each of those cases. In this case, in the in list, because errors register as true. So I'm going to use string.join. In this case, it should work across the lists, I believe. And the separator we'll use in this case is comma space. So we'll just get commas between each of these errors, and that should give us something a little bit more logical. So we can see the first 2 views cannot be placed. We know that's true. The 5th one, which in this case is I believe the level 4, has no view, so it cannot be placed either. The last one is the sheet is not found, and the view cannot be placed. So we've got a pretty good little error report here that does make a lot of sense. So what I'm going to do here is just basically build off 2 conditions. I want to get rid of any empty lists. So I think in this case I probably just can say is empty. I'm just checking. I'm currently dealing with a list in a list. So I do want to probably just take that list out using an index to make sure we're just dealing with a list object. I can now actually, these aren't lists anymore, are they? No, so I have to say is that, I'll say this is my report. And then I'll just say, does report equal to an empty string? So I'll get a true false outcome, which again, I can Boolean mask. And in this case, it's a very simple mask. Now I only get the errors, but I also know which ones have an error report. So I can also get another Boolean mask and go back and mask, in this case, way back here, the sheet plus the plan plus the name. So I can then see the human readable readout of the sheets and views and names that generated an error. So these are two more outputs I can give my script. So I'll just copy my viewports created output. Now the first thing I probably want to report is where errors occurred using the out list here, the ones that aren't empty. And I'll just say viewports not made for, and then my last output in this case will be errors. So error reports. And now the users will only see the 4 that did not work, and then the error reports for the 4 that did not work. So let's just very quickly just neaten up this script, but at this point we have a really functional little tool. So I'll say read and process Excel data. Now we'll try running this from Dynamo Player to finish, but I believe this is it. I think that works. We'll say run the Python script, place viewports. We'll process the error reports, so I'll just move that over just a little bit. And we'll say this is process error reports. These are the color codes I use at work for Dynamo. So generally color coding I use here. Green is inputs where the user provides input. Orange is automatically collected inputs, such as collectors of objects. Blue is generally things happening that modify the model. Purple is processing of data, and pink is usually outputs to the user. When I used to use data shapes, I used to use green for anything that dealt with user interfaces, but I don't use data shapes anymore. So filter the outcomes, and finally report the outcomes. Whoop. So in this case, we haven't used any custom nodes in this case, which is really cool. But also to the user, I think it's a really clean, understandable script with a lot of troubleshooting steps along the way. So let's just save this script, and I might just call this final script place views on sheets. And we're going to try running this through Dynamo Player. So I'm going to go back a step before I ran this. Open up Dynamo Player, which for 2023 looks a little bit different. Should open up in a sec. And we're just going to add my desktop. Now I should be able to pick my desktop, and I can open up place views on sheets. Pick in this case an Excel file. Sheet 1 is my target. Run the script. You can see we've got viewports created. The error, the inputs or outputs aren't in the best order. We can see that there's 4 errors for these ones here. I think it's alphabetically sorting. Yeah, not great. And then we can see we couldn't place views on ground floor plan and level 1, which makes sense because we already placed them. Level 4, we couldn't place it. So we can always fix these issues. Let's just fix them. So I'm going to duplicate this sheet as empty. We'll say 2004, level 4. Let's create a level 4 floor plan. And now, if I rerun the script, you can see we created those 2 new viewports, and the rest of them obviously triggered errors because typically the views can't be placed because they already exist. But there we go, we've just satisfied that problem. So a very flexible script that's very user-friendly with a lot of steps involved in order to make sure that's the case. So if you want this script and other resources, you can find them over on my GitHub. I hope it was an interesting tutorial, and it also taught you about good practice in building user-friendly tools. So if you're not already following and subscribing, feel free to do so. Feel free to leave comments with requests. I can't guarantee I'll do them all, but I will try the ones I can do, and I will reply to all comments as well. So I hope you found this useful, and if you're learning about the Revit API, maybe it helped you see how I work with the Revit API. I tried to really take some time there to show how I access the API docs and look through various things I'm searching for, classes, methods, properties, enums, etc. And I look forward to seeing you in future similar videos. Thanks. Take care. Bye.